Is it visible to everybody?
Yes, ma'am.
Okay. Let us start now today. In last week or in previous lecture, we have started about the analysis of doubly reinforced beams. We have seen the basic concepts of doubly reinforced beams, and then we also gone through the various formulas which are used to find out the depth of neutral axis as well as moment of resistance of the doubly reinforced section. We have discussed about the analysis of the sections, doubly reinforced section using mild steel. We followed specific steps for finding the moment of resistance for doubly reinforced section using mild steel. Okay. We also started solving one problem and we have completed the part A of this problem. Today we will complete part B of the problem and then we will go to the next point, that is how to analyze the beam when HYSD bar steels are used. Okay, so I hope everybody is having this problem statement with you. Let us consider the B part now, that is the second problem. So I'm opening now the whiteboard. Tell me the given data now. Yes, quickly tell me the given data.
5 bars with 20 mm diameter.
Okay. Given data. It's a B problem. So AST I will directly calculate 5 bars of
20 mm dia.
okay 20 square into 5 AST, and also the details of steel in compression zone is given. So what are the details?
2 bars of 20 mm dia.
Okay, we're talking about second problem. Huh?
Yeah.
So quickly tell me the AST value and ASC value.
1570.79.
Okay.
Ma'am, for the ASC, it's 16 mm bars.
16 mm. Confirm?
Yes.
Yes. Yeah. Sorry, ma'am.
ASC
Ma'am, there are
16.
5 bars. Ma'am, there are 5
We
bars
are
for ASC.
we are talking about the second problem. Huh?
Yes,
Yes,
ma'am. Yes,
ma'am.
ma'am.
5 balls
Huh.
of 16 mm.
Okay. So it is 16 mm, 5 bars, right?
Yes, ma'am.
Tell me the area.
1005.30.
Okay, fine. So as per the steps, I hope everybody is having the steps with you also. What is the first step? We have to calculate
Yes,
Assume
yes.
XU first. Or for that we have to assume the FSC value first. Okay. So let us assume FSC as 0.87 FY. Now here FY value we have to take as, what is the given value? 250.
250.
250.
Yes, 250 Newton per mm square. So what is this value? FSC 0.87 FY
17.5.
to
17.5.
okay. All right. Now the next step we have to find out XU. So what is the formula of XU? .87 FY.
AST
Yes.
minus FSC
Hmm.
into ASC
Hmm.
by 0.36 FCK into B.
So let us put the values here. I'm taking 0.87 FY common, or simply I will put the values 250 into bracket AST value is 1570. 0.79 minus 217.5 FSC into ASC is 1005.30 divided by 0.36. FCK is 20, right?
Yes, ma'am.
And what is the B value? Width?
300.
300. So tell me now XU value.
56.94.
56.94 mm. Okay. Now for the given grade of the steel, we already calculated XU max in last lecture only. So what is the value of XU max?
180.2.
180.2 mm. That is the XU max value.
Yes, ma'am.
Correct. So compare the XU value with XU max. XU is coming less than XU max. So what is the type of the section?
Under reinforced.
Okay, so the section is under reinforced. Now what is the next step?
FSC calculate.
FSC calculation, right. So let us calculate FSC now by using the XU value. So the formula of FSC, tell me quickly.
700
Mhm.
in bracket 1 minus DC upon XU.
Correct. So 700 into bracket 1 minus, what was the DC value?
40.
40.
Okay. 40 divided by XU is right now what value, which value we have calculated?
56.94.
56.94.
94.
Okay. So find out FSC now for this same values.
Ma'am, 208.25.
208.25.
25.
Okay. This is the FSC value, that is a stress in steel in compression zone. Now we have to compare this value with 0.87 FY, okay, to check whether our assumption is correct or not. What is the criteria? What is the given condition? If it is coming greater than 0.87 FY or equal to 0.87 FY, it means our assumption is correct. If not, it means our assumption is wrong and we have to recalculate XU by this FSC value, by considering this FSC value, or by putting the FSC in terms of XU, we have to recalculate XU value. Okay, so let us compare this value with 0.87 FY. The 0.87 FY value we have already calculated earlier and it is 217.5. Okay, so this value is coming less than 0.87 FY, that is 217.5. Okay, what this it indicates? FSC is
Assumption
less
is
than,
wrong.
correct.
Wrong.
So the initial assumption is wrong. Assumption is wrong. And we have to calculate now XU by putting FSC value in terms of XU. Okay. So just write down recalculating XU, recalculating XU by putting FSC is equal to, now the formula we already know, 700 into bracket 1 minus DC is nothing but 40, value we already know, divided by now XU. In terms of XU, we have to write down the FSC value, and this FSC value we have to substitute in XU formula. So I will write down again the XU formula as 0.87 FY into ASD minus FSC. Now I will put this value 700 into bracket 1 minus 40 upon XU into ASC divided by 0.36 FCKB. Okay, now simplify all these terms and you will get or put the values of all the parameters, that is Fy, AST, ASC, FCKB, all these values put in the formula, and you will get one quadratic equation because there are two XU terms here now. In this equation, there are two XU terms. So simplify and tell me what is the quadratic equation you are getting. Guys, are you doing na?
Yes, ma'am.
What is the equation you are getting? I will just write down the equation what I have obtained. Check whether the same value you are getting or not, or the same equation. So it is 2160 XU square plus 362068 XU minus 28.15 into 10 raised to 6 equal to 0. Check whether you are getting the same equation or not. And then you have to find out the roots of this quadratic equation. You will get two values for XU. One is positive, another is negative. Obviously, we have to consider the positive value. Have you got the same equation? Students? Hello? Are you there in the class?
Yes, ma'am.
So have you got the same equation? If not, do these calculations later on and check whether you are getting the same equation or not. Tell me now the roots of this quadratic equation. What is the XU value you are getting? We have a short of time, so I'm running now. What is XU you are getting?
57.8.
Correct. 57.8 mm. Now, if you observe this value of XU, it is different than the earlier value. Earlier value was 56.94. So there is a slight increase in XU value. Okay. Now, we have the XU value, we will again calculate FSC. Because we have not calculate FSC, we have put the FSC formula in XU expression and then we calculated XU. So let us put the XU value here, the newly calculated one, in the FSC equation. Again, we have to check the value of FSC against the maximum value, that is 0.87 FY. So let us calculate FSC now again. So FSC is equal to 700 into bracket 1 minus 40 divided by 57.8. So what is the FSC value you are getting? Guys?
Ma'am, 215.57.
215.57.
215.57.
57.
Okay, Newton per mm square. Compare this value with the maximum value of 0.87 Fy, which is 217 point. What is the value? 217.5. Okay, so this value is coming less than again 217.5. Okay, and we have already calculated for this condition, that is if the FSC value is less than 0.87 Fy, we have put the FSC in terms of XU in XU formula. We calculated the XU and we recalculated FSC. So this is our final value of FSC and XU. Okay. So for this value, now we will calculate moment of resistance. So moment of resistance. MUR, tell me the formula. 0.36 FCK B into XU, am I right? Into bracket D minus 0.42 XU plus, what is the formula? Tell me.
FSC into ASC in bracket D minus DC.
Correct. So put all the values here. 0.36 into FCK is 20, into B is 300, into XU is the latest value of XU we have to consider for the calculation, that is 57.8, into bracket D is 300 minus 0.42 into 57.8. I'll write down this fact. So this is 300 minus 0.42 into 57.8 plus FSC we have calculated as 215.57 into, what was the ASC value? ASC
1005.30.
0.30. Okay.
Ma'am,
Into
D is 340.
Effective depth D. Last time what we have calculated?
Ma'am, 340.
Yes, ma'am, 340.
So all earlier calculations will go wrong now. Here, okay, we haven't used D value anywhere up till now. So, okay, nothing is wrong. All values are correct. All right. So D value here, I have to make correction, right? So D value is 340. And this is also 340. So this is 340. Okay. 340 minus DC is 40. So tell me MUR value.
$104.43.
Okay. 104.46 kilonewton meter. Correct?
Ma'am, 43.
Okay. $43. Okay. So this is our final MUR value. So is it clear how to calculate the MUR value for doubly reinforced section when we are using the mild steel? And we have considered two cases. In the first case, we found that our initial assumption, that is FSC equal to 0.87 FR, that assumption we found correct, and we directly started calculation of MUR. But when the same assumption comes out to be wrong, through this calculation, we have to repeat some calculations as we have done today. Okay, so in this problem, we have calculated first the XU. Compared with XU max, we found that section is under reinforced. Then we calculated FSC for the calculated XU value. We compare FSC with 0.87 FY and we found that it is coming less than 0.87 FY. So our assumption is wrong, initial assumption. So we recalculated XU by putting the FSC in terms of XU. We got one quadratic equation. We solved it to XU value, which is 57.8. Again, we calculated the correct value of FSC, and these two values we have finally put into the moment of resistance equation to find out MUR. So the process becomes little lengthy when the initial assumption of FSC equal to 0.87 FY comes out to be wrong through the calculation. Okay, is it clear? Both types of problems we have solved here. Yes.
Here we have calculated FSC value again, but it is still less than the that 0.87 FY.
Fine, correct. But we have calculated here the correct XU value, no? Earlier, what we have did, we have directly assumed the FSC value as 0.87 FY, which is not coming true. Okay, 0.87 FY value we have taken as 217.5 initially. Okay, and we calculated XU. So XU value is for this FSC value. And then we calculated FSC and we compared it with 217.5. So what we are expecting that the FSC value will come greater than or equal to 217.5. It is not coming. That's why the earlier calculated XU value is wrong. And hence we calculated XU again by putting FSC in terms of XU. We got the correct XU value. Then we calculated the correct FSC value. See, FSC value even after calculation will come less than 0.87 FY only. Okay, as per the requirement or as per the calculations, if you refer back the earlier lecture, FSC value we have to limit always to 0.87 FY. The value should be either less than or equal to 0.87 FY. Okay, if it is greater than 0.87 FY, we consider it as 0.87 FY. We take its value equal to 0.87 FY and use that value for further calculation. Okay, but if its value is coming less than 217, our initial assumption of equal to 217 was wrong, and hence we needed to recalculate everything. Okay, so these problems, when you solve at the first time, it is difficult to understand in the first attempt. You go to the steps, whatever we have written earlier, read it again and again, and read these problems again, whatever you have written in your notebook. Okay, then you will understand how we have solved the problem. Is it clear?
Yes, ma'am.
Yes.
Okay. Now, let us come back to the presentation and we'll move ahead to the next point. That is, when we use HYSD steel bar, how to analyze the problem. That is, how to find out the moment of resistance. Okay, so these are the steps for HYSD bar. All of you are requested to write down, note down these steps. Let me read first all the steps. Again, the first step is same as per the earlier case, that is when we use mild steel. First, we have to assume the FSC value, which is equal to 0.87 FY. We will calculate XU. If XU is coming greater than XU max, as per the codal provisions, we have to limit XU to the XU max. Okay, and based on this comparison, again we have to decide whether the given section is under reinforced or over reinforced. Then we do not calculate FSC directly in case of HYSD steel. In the previous lecture already we have discussed why we cannot calculate FSC, and whatever the formula, that is 700 into bracket 1 minus DC upon XU, this formula is not applicable for HYSD steel. This is because the stress strain curve for steel is not completely linear. That's why we calculate the total strain first. Okay. Now in the previous lecture we have prepared two tables, if you remember. One is for FE2415 and second is for FE500. And for both these grades of steel, for different values of design stresses, we calculated the total strain. Just to recall, I have added the table for FE415 here again during today's lecture. So we have calculated all these total strain value. The maximum strain can be achieved equal to 0.0038, corresponding to the maximum stress of 0.87 Fy. So in the steel present in compression zone, that the stress in that steel we always consider equal to maximum 0.87 Fy. Okay, so or in other terms, I mean to say FSC is considered equal to or is limited to the maximum value of 0.87 Fy. So corresponding to this maximum stress, what is the maximum strain? That value we have with us. So that value we have to check first. Okay, epsilon SC formula is already known to us. What is that formula? You just refer your notes of earlier lectures and tell me what is the epsilon SC formula. Students, have you understood my question?
0.0035 minus DC upon XU.
Correct. 0.0035 into bracket 1 minus DC upon XU. That is the formula of epsilon SC. And based on that, whatever the epsilon SC value we obtain, we have to compare it with this value. Okay. Why this value? Because this is the maximum value of total strain corresponding to the maximum stress of 0.87 Fy. So compare the value with this. For Fe415, if the grade of steel is Fe415, if it is Fe500, the same value is 0.00417. Refer the table for Fe500, which we have prepared in the previous lecture. Okay, so the maximum value is 0.00417. Now, if the calculated epsilon SC value is greater than this value, assumption is correct. Okay, or epsilon SC value is greater than 0.00417 for Fe500, our assumption is correct, because when epsilon SC will exceed this value, obviously your FSC will be exceeding 0.87 Fy. Okay, the same concept is here. Only the thing we cannot calculate FSC directly by using some formula. So we are calculating total strain and we are comparing the maximum value of total strain corresponding to maximum FSC value. Is it clear? Is there any doubt up to this?
No, ma'am.
Okay. So if your epsilon SC value is coming less than these values, then our assumption is wrong. Okay. In that case, again, we have to calculate the FSC. Now, how to calculate the FSC? See, again, I'm repeating. We have considered this value directly by assuming that FSC is 0.87 Fy. Now the value is coming less than this value. It means the corresponding stress is also less than 0.87 Fy. And that stress value we have to calculate by making use of this table. So suppose after calculation here, your epsilon SC value is coming, say, 0.00250. Let us assume this value. Epsilon SC is coming as 0.00250. So it is less than 0.0038. I'm assuming Fe415. So I have to calculate now FSC from table. So for epsilon SC equal to 0.0025, refer the final column of the table. 0.0025 value is lying between these two values. That is 0.00192 and 0.00241. The value is in between these two. So I have to interpolate the value of 0.0025 between the range of 0.00192 and 0.00241. Considering the corresponding design stress values of 324.78 and 342.83 respectively. Okay, so after interpolation, I will get the value of stress here, that is FSC value, which will be between these two values, that is 324 and 342. Between these two value, I will get the FSC value. So once I will calculate the correct FSC value, again I have to recalculate XU. Okay, then again I have to calculate epsilon SC, because in epsilon SC formula also XU is there. Again we have to check now the epsilon SC with this criteria. Okay, again our value, if it is coming less than 0.0038, again we have to calculate FSC. Now these steps we need to keep on repeating till you get FSC value constant. Okay, so iterations, you must have learned the iterations in mathematics in your school or primary college days, right? So or 11th 12th. So iterations, we have to use that concept of iterative calculations for FSC here. And once we get the FSC value constant for 2 consecutive iterations, we adopt that value for the further calculation of mu. Is it clear? Steps. See, these steps will be clear to you only when you solve again the numerical example. Guys, is there any doubts in this?
No, ma'am.
Okay. So let us move to the problem statement now. Again, the same problem we will solve now by considering Fe415 grade steel. So you just note down this problem and we will quickly start solving the problem again. I'm giving just 1 minute for all of you to write down. It is the same problem statement, only I have changed the grade of the steel. So shall we start problem solution? Guys? Today response is very poor. Huh? Students? Shall we start solution?
Yes, ma'am.
Let us consider now the first problem, that is A part. Okay. So for A, write down the given data again. All those calculations are with you. So quickly tell me AST value directly, because we had already calculated that value in the earlier problem. AST value for A, case A.
1884.95.
Pardon, please. Pardon, please.
1884.95.
Huh? 90. Okay. AC
628.31.
point
31.
31.
AST AC. FY value is different now. Here it is 415 Newton per mm square or megapascal. Okay. So as per the first step, again we have to assume that FSC equal to 0.87 FY. Now put the value of FY here and tell me what is the value of FSC you're getting. It is 0.87.
361.05.
361.05.
05.
Okay. All right. Now let us calculate XU. So it is 0.87 into, I'm directly putting the values today, FY into bracket. I have taken this as common. So it will be 1884.95 minus 628.31 divided by 0.36 FCK into B. Okay. So tell me the XU value now.
6.91.
Pardon, please.
86.91. 86.91.
Are you sure?
Yeah, man.
FY value?
I will do.
210.05.
The value is different. FY value you must have taken 250 and that's why your value is coming lesser. FY value is 415. So the XU is 210 mm. Okay. Now tell me the XU max value. XU max value will be different now because we have changed the grade of the steel. XU max completely depends on FY value. So look into the IS code and tell me for FE
Ma'am,
again.
0.48.
0.48 into D.
Correct. So tell me the value. 0.48 into D is 340, right?
Yeah, ma'am.
So XU.
300.
300.
163.2.
What's happening? Calculations are going wrong today, huh? 163.20 mm is the XU max. Now compare XU with XU max. XU is coming greater than XU max. What this indicates? The section is
Over
the
reinforced.
section is
Over-reinforced.
over-reinforced. Now in case of over-reinforced section, we have to limit the XU value to XU max. So taking XU equal to XU max value, that is equal to 163.20 mm. Okay, now for this XU value, we have to calculate epsilon SC. Okay, so the next step is calculation of epsilon SC. The formula is 0.0035 into bracket 1 minus dc upon XU. Okay, so let us put the values. 0.0035 into bracket 1 minus dc is 40 divided by XU is 163.20. Tell me the epsilon SC value.
.64 into 10 raised to minus 3.
Tell me in terms of point. 0.10 raised to minus 3 na? 0,
0.00264.
ठीक है. Now compare, we have to compare this value with the maximum value, that is 0.00380. Am I right? As per the steps. You have just now written the steps now. So compare the value with 0.0038. This value is coming less than 0.0038. So what does it indicates?
Assumption wrong.
So the initial assumption is wrong. Initial assumption means our FSC value is wrong. Okay. Now to calculate the correct FSC value, we have to find out the FSC value from the table. Okay. So just write down the sentence. Recalculating FSC from table. Okay. So let me go to the table again here. In the table, the value, see epsilon SC value is 0.00264. So if I will refer this table here, 0.00264 value will lie between these two values. Okay, so just keep these values in your mind, 0.00241 and 0.00275. Somewhere you write down, or better you keep the table open. Keep the table open now in front of you, whatever you have prepared earlier. So I will write down now the epsilon SC values here, epsilon SC values and FSC values, which are the corresponding stress values. So epsilon SC value is in between 0.00241 and 0.00276. The calculated value is 0.00264. Okay. Now corresponding to this epsilon SC value, what is our stress? Can you tell me from the table?
342.83
Yes.
and 351.85.
351.85. Correct. Corresponding to this, we want to find out now the unknown term Z. Okay. So let us do the interpolation. I hope everybody remember how to interpolate the values. So 0.00276 minus 0.00241 divided by 0.00276 minus 0.00264. If you are able to calculate or do the interpolation directly on the calculator, you can do it. I always use this very old method of calculation. Okay. So we have to cross multiply now the values. So it is, what is the difference? 0.00276 minus 0.00241. 0.00276 minus 0.00241. It is 0.035 divided by 0.00276 minus 0.00264. It is 0.00012 is equal to 351.85 minus 342.83.
Ma'am, numerator is wrong.
Why? Why wrong?
Ma'am, it will
This
be
one?
point
This one?
not should be not 35. Yes, ma'am.
Okay. Let me check again. 0.00276 minus 0.00241. Correct. 0.00035. Correct. Now 351.85 minus 342.83, 9.02 divided by 351.85 minus Z. So complete the cross multiplication step and tell me the Z value.
$348.76.
Let me check. Correct. 348.76 Newton per mm square. So this is my FSC value. I'm getting FSC as 348 0.76 Newton per mm square. Okay, now I have obtained the correct value of FSC. I need to calculate XU again now. Okay, so XU is equal to, I will simply write down the formula here. You have to write down all the values again. 0.87 FY ASD minus FSC into ASC divided by 0.36 FCKB. Put all the values and tell me XU value. That is 0.87 into 415 into AST is 1884.9 minus FSC is 348.76 into AAC is 628.3 divided by 0.36 into 20 into 300. What is X you are getting?
213.61.
Correct. 213.61 mm. Compare this XU now with XU max. What was the XU max value? Let me check. XU max is 163.20. 163.20. So this value is coming greater than 163.20. It means our XU value will be equal to XU max here, that is 163.20. And this value only, for this value only, we have done all these calculations. Here, we have calculated the epsilon SC value for this value only. Okay, so rest all calculations are now correct, and whatever the FSC value we have calculated is also correct. So XU is equal to this and FSC equal to 348.76. By using these values, now we can find out MUR. So finally, the moment of resistance can be calculated. Moment of resistance MUR is equal to it is, formula is 0.36 FCK B into XU. XU is 163.20 into bracket B minus 0.42 XU plus FSC. What is the FSC value now? It is 348.76. 348.76 FSC into AC. AC is, I think, 628.3. Am I right? AC, yes, into bracket D minus DC. Okay. So find out MUR.
One 161.42 kilonewton meter.
Yes, 161.42 kilonewton meter. This is the MUR value. Correct. Is it clear how we have solved the problem now? Guys?
Ma'am?
Yes, ma'am.
Huh?
Ma'am, in this, when we did the second iteration, we got XU as 213.6, which is greater. So if we would have gotten that less than 163, then we would have to repeat the whole process again.
Yes, correct.
Okay. Okay, ma'am.
For newly calculated XU value, we have to again calculate epsilon SC, then again FSC. All that will have to be repeated again.
Okay, ma'am.
Okay. All right. Then let us come to the B part. I am slightly extending today's lecture by 10 minutes because I want to finish the second problem also. So let us solve the second problem. So tell me now the given data for second problem.
AST is 1570.79.
Just a moment. AST is
1570.79 and ASC is 1005.30.
all right. So the first step is again assuming FSC is equal to 0.87 FY. What was the value? 3 something na?
361.05.
Okay. Now calculate XU. So it is 0.87 FY into bracket. AST is 1570.79 minus 1005. Again, I have taken 0.87 FY common divided by 0.36 FCK into B. So tell me XU value. What is the XU value?
$94.52.
94.52. Okay. Compare this value with XU max. What is the XU max value which we have already calculated? It is 0.48 D. So what was the value?
163.20.
Okay. So XU is coming less than XU max. It means the section is
Under reinforced.
under reinforced. Correct. Now let us calculate epsilon SC. Epsilon SC is equal to 0.0035 into bracket 1 minus DC upon XU. XU is 94.52. So what is epsilon SC you're getting?
Zero point zero zero two zero one 202.
0.00
202.
202. Okay, 202. Okay, now again we have to check this value of epsilon SC into the table for finding FSC. So I will go back to the table now. In the table again our value is 0.00202. So let us consider 20 only. So 0.0020, this value will lie between these two values, that is 0.00192 and 0.00241. So for these two values and these two values corresponding values of stress, we have to again do the interpolation. Okay. So let me write down here. Again, the epsilon SC values and FSC values. So epsilon SC, it is between 0.00 192, then 0.00202 and 0.00241. Okay, corresponding to these, please tell me the stress values.
324.78,
Hmm.
342.83.
Correct. So in between, I have to find out now this FSC value. Okay. So I have shown you the interpolation. Just do that interpolation. If you know how to use the commands directly in the calculator, you can use it and tell me the FSC value. I'm not writing now all the steps again here. So tell me FSC. Guys, are you doing the calculations?
Three 28.46.
320.
8.46.
Okay. 328.46. All are getting the same value? Because I'm getting a little lesser value.
263.20.
No. 263. No, no. Any other answer?
Yes, ma'am, same. 328.46.
Same. Okay, fine. I was getting 327.74. No problem. It is just difference of point, just a difference of 1 Newton per mm square. Okay. So let us now calculate for this FSC value XU again. Okay. So again we will put the value of all the parameters 0.87 FY into AST. AST value is 1570.8, right? The same one. Let me check. Yes, 79. All right. So this is 0.79 minus FSC is 328.46 into ASC is, I will write down here, 100.3. Okay. Divided by 0.36 FCK into B. So XU is coming as
109.69.
109.69 mm. Compare this with XU max. XU max value is, what was the XU max value? It is 163.20. So this value is again coming less than XU max. Okay. Now for this XU value, see if you compare the earlier XU value, the first one, it is 94.52. Okay. And now the XU value, we have got the new value 109.69. Okay. For this value now, again, we have to repeat all these steps. Okay. So again, we will calculate epsilon SC for this XU value. Epsilon SC is equal to 0.0035 into bracket 1 minus 40 upon this XU value 109.69. Okay. So this epsilon value is coming equal to, what is the value? Quickly tell me.
0.00222.
0.0022. Now the earlier epsilon value was 0.0020 and now this is 0.0022. So again we have to do the interpolation. The interpolation range will remain the same. The same range we have to do, but this value is different. So FSC value will come out to be different. So again, let me check whether I can copy this or not. No, it is not possible. Okay, so again I will write down here epsilon SC. What is the first value? 0.00192. Then our value is 0.0022. Then 0.00241. And the corresponding FSC values are
324.78
hmm,
and 342.83.
correct. Again, I will find out the FSC here. Okay, so after calculation, I am getting FSC. I will write down the value directly here. It is coming as 335.09 Newton per mm square. Okay. So again, if I will go back to the FSC value, earlier FSC value, it is again something different. 328 and this one I am getting as 335. So again, I have to go to the next iteration. That is again, I have to calculate XU, then epsilon SC. See, this process we have to keep repeating until we don't get the constant FSC value. Okay. So I will directly write down the value of XU. Next, for next iteration, I'm getting the value of XU as 106.60 mm. Guys, you can solve the further steps of the problem as a homework. As the time is limited, I am writing directly the answers here. So for XU now, again we have to calculate epsilon SC, which is coming out as 0.00219. So I can take this value as 0.0022. Okay. So if you compare this value of epsilon SC, it is the same one, 0.002. For which we have already calculated FSC as F30 335.09. So finally we got the constant value of FSC as 335.09. Okay. So for this value, now we can calculate MUR. So you will just put all the values in the equation and check whether you are getting the same answer what I am writing here or not. Okay, this is the final answer, MUR. Is it clear, guys?
Yes, ma'am.
So we have solved two cases now by considering HYSD bar. In the first case, we got the type of a section as over reinforced, and we found that the number of iterations required for over reinforced sections are less. And in the second case, we found the type of section as under reinforced, and number of iterations required for that are more as compared to the over reinforced section. Okay, so this is how we analyze the doubly reinforced section when the type of a steel is HYSD bar. Is there any doubt in all these entire solution, everybody? We have to do the repetitions till we don't get the FSC value constant. Any doubts in this?
No, ma'am.
Okay. So now we have solved this also. Next lecture, we will start with the next point, that is the concept of flanged section and how to find out the moment of resistance for plant section. So give me the attendance now through this link only. I will keep this link open for next 10 minutes. Everybody has to give the attendance through the link. Okay, guys. So let us meet for the next lecture. Tomorrow we are having a holiday. Huh? Tomorrow there will not be any lecture and practical. We have a holiday on account of Anant Chaturdashi. Okay, we'll stop the lecture today now.